During this Lunch and Learn, recorded on July 13th, 2021, join Maggie Smith, Director of Children's Programming at CodeVA's Eureka workshop. Learn more about the arts integration computer science approach her department takes to bring computer science to all students. Maggie demonstrates multiple unplugged activities using simple tools like play-doh and blocks that can be used with students at any level to teach computer science concepts.
Fantastic. Thank you, Brian. I really appreciate being here. Super excited to be able to work with the educator enrichment side and the educator community that CodeVA has built. So like Brian said, I am the Director of Children's Programming. In addition to all of the awesome training and PD that you all are doing, another thing that CodeVA does is work directly with kids. So we do out of school time programming. We do summer camp, after school, winter break camp. We have a robotics league that we run through Eureka workshop. Sometimes we go into schools and do a little bit of enrichment in different teachers' classrooms. So we have a wide variety of programs that we provide directly to students. And the really unique thing about Eureka Workshop is almost every single thing we do is arts integrated. So my belief is that there are a million different types of learners. And so all learning should have a little bit of everything. And my brain is very visual and arts and hands-on based. And believe it or not, when CodeVA started, I was like, nope, computer science, it's not for me. I'm not that kind of person. I can pick out all the colors for you, but I can't code. I can't do the computer part. And working with Rebecca Dovey, our Director of Education here at CodeVA, I quickly learned that computer science is not this big, dark cloud of unknown that only the super brilliant folks get to enjoy, but that it's around us every day. And the first thing that we really talked about was binary code and weaving. So I love fiber. Weaving over, under, on, off, black, white, 1, 0. And I was like, oh, it's just that simple. And to me, weaving is simple. But I think to someone who maybe is a computer programmer, they might think that weaving is difficult. And so it was the merging of those two concepts that made me really get it. And I was able to learn with our students as we started CodeVA and started summer camps in this arts integrated program. So as instructors, as teachers, as we all are here, something that I think is super important that we all do every day and is probably doesn't register with the rest of the world, it's scaffolding. So we are planting seeds. We are giving students concepts and vocabulary to support their way up to that aha moment, right? And I view unplugged activities with younger students to be the ultimate scaffolding. So not only for the learner, but also for the families. And in our out of school time programming, I see 3 main mindsets in families. One is that the grown-ups in that family are saying, technology, computer science, it's over my head. I don't want to set my child up for failure. We're not doing this. Another mindset is computer science, technology, STEM, STEAM, all of those things are super important for my child to be successful. They confuse the heck out of me. I don't know what's going on, but I know my kid needs that and they need it now. The third group of families where the grown-ups are already involved in technology and they understand the importance and they want their kid to have it immediately. The grown-ups in these families don't really, in my opinion, it doesn't seem like they really consider how they got there. And so they want their 7-year-olds to learn JavaScript in a 15-hour summer camp. So all of these views, these are the most common views that I see. And I think that unplugged activities for families is a really wonderful way to help support our students in getting a proper foundation in computer science. So when I'm talking about unplugged activities, I'm talking about any activity that does not involve a screen and typing, that introduces a student to a computer science concept. And through an arts integrated view lens, this could be a million different things. As I mentioned earlier, weaving, and combining a binary code with a weaving project, or even Morse code and a weaving project. But I thought today I would show a little bit of some of the things that we do here at Eureka Workshop. And we work with students from rising first grade all the way through seniors in high school. And a lot of the things that we do can be scaled all the way from the littles to the high schoolers. So I'm going to share a video. Well, actually, I'm going to step back 1 second first. Something that I think is really important about computer science is getting the student to understand that the computer is not a genius. It doesn't just magically do the thing. The humans are the geniuses, and they are programming the computer to complete the task. And being able to communicate to that machine clearly what needs to happen is what computer programming is. In my educational experience, I had a lot of, this is how you follow directions, but never did anyone say, this is how you communicate instructions or directions. And so that is something that we work on a lot, and all of the activities that we touch on today will have to do with that concept of getting students the confidence and ability to create instructions for a computer or a human to follow. So the video that I'm going to show you is a group of high school students. And one of the students in the video is actually our office assistant who's in the building now, which is super cool. But this is, I think, from 2018. And an activity that we do all ages, and we don't even change anything for it, is programming your friends. So in this video, what we've done is we had this group of high school young men. One student left the room, and they created a maze on the floor using masking tape. And then the student who had left the room was blindfolded and returned. And the students who made the maze had also created a language, a computer language. So they had 5 phrases, only 5 phrases that they could use to get the blindfolded student from the beginning of the maze to the end of the maze. And so this is just a super quick video. We'll see how well I do sharing here, of our students from Richmond Cycling Corps going through a maze, and that is Jamboard. Okay, Brian, do we have a thumbs up on the video? Okay, so here we go. And this is just a quick time lapse of these students directing through the maze. And every time the student hits a roadblock, they need to go back a little bit. So here we have high schoolers that had the best time, and 3 years later still talk about this and how much fun they had. And this is something that we do with first graders all the way through 12th graders, and we don't change anything about it. I feel like this is an activity that is actually more difficult with grown-ups. So recently I did this as an icebreaker with a group of adults, and everybody wanted to give so much detail that it got confusing to the person who was blindfolded. And so I think having students do this exercises and really learn that like concise, clear communication not only helps with computer science, but also helps with our interpersonal exchanges through life. So that, to me, is just another reason that unplugged activities are beneficial for students. And how many folks have been using Jamboard during this virtual time? Get some raised hands, or maybe not. Well, with Eureka going to virtual classes, Jamboard is a tool that we've relied on quite heavily. And this is a tool through Google Suite, sorry, I got distracted. I have found this to be a really useful tool while engaging with students virtually and still doing an unplugged activity. So we are operating virtually, but they're still getting this computational thinking with a hands-on activity. So like the maze, I call this the instruction manual. And what we do is we have, I'm gonna switch cameras for you. So we start with 2 sets of identical blocks. And for, these are not set up identical. Let's see if we can get that identical. These, by the way, are a $3 set of Jenga from the One Spot at Target. And I love these little blocks. You can use them for all kinds of things. But we will give 2 students a set of identical blocks. And one student, which we're gonna be a team. And I'm going to make a formation and move it under here. So actually, let's do it this way so it's kind of perpendicular. So this is our formation. And In real life, we would have students sit back to back, and one student would make a formation, the other student would have their set, and the student who made the first structure would give instructions to the other student on how to place their blocks to replicate what the first student had done. So this is a little difficult in the virtual land. So something that we have done in our classes is to do this in Jamboard. And I have, let's see if here is a Jamboard link that you all should be able to access. And I would like for folks to, I don't know if, Brian, can folks unmute in this meeting?
Sure can.
Okay, awesome. So I'm gonna leave my screen up so you can see the formation. And I would like for folks to unmute and give me instructions on how to draw this formation that we have. And Brian, if you want to give me the first instruction, that would be cool.
Sure. So let's see. What are my options for you to draw, Meg?
I have a pen, a marker, and a paintbrush.
I would say for you to take a marker and color it yellow and draw a vertical line. There might be more than one instruction, I don't know.
Okay. Does someone want to give me another instruction?
Get a blue marker and make a line perpendicular to the yellow line.
Okay.
Can I adjust my instructions or I just get one?
Yeah. Yeah, we can take a step back.
Okay. Erase that blue line.
There we go.
Okay. And make it perpendicular, the same blue color perpendicular to the center of the yellow line.
Oh, okay. All right.
And now erase the left side of the line.
Erase
the left side of the blue line.
Okay.
Okay, I'm done.
Who? Anybody else? So have I created the formation? I'm gonna
take a purple marker if you have one, and go towards, not exactly at the tip of the blue line, on the opposite side of the green, and draw another vertical line down.
Down.
Let me see.
Okay. I'm using red instead of purple. All right, so as you can see, we got it pretty darn close. That's amazing. I'm going to come back and switch and share Jamboard, just in case some folks did not see what we created. But we have this very close formation. You guys did a really good job. I understand it is your full-time job to give instructions, so way to go. But if you were in Jamboard, another thing that you could do with virtual students would be to have someone draw anything on slide 1, and then on slide 2, if you have older students, they can write instructions. So step 1, draw a yellow vertical line. And then the next student would follow those instructions here, and they could go back to check and see if they got the instructions done correctly. And now couldn't figure out how to stop sharing. Okay. Yes, Brian, we totally did it, and I couldn't see your comment because I was in Jamboard. Another way to do this, and this has become a really wonderful writing exercise with students, and it's the exact same project, but you can just tweak it and get it to be the right thing for the set of students you have in your classroom at that time. So here I have 2 cups, and they have the identical sets of Legos in each cup. So the several ways you can do this. One, you can do it just like the drawing and have the students back to back and have them give instructions on how to create the structure. Another thing that you can do is give 2 students the cups with the identical Legos in it, send them on their separate ways, and have them write an instruction manual for creating they create whatever structure they want out of their given Legos. And then they write an instruction manual, and then they trade pages. So they're trying to make the other one's creation. And I'm a big fan of drawing, and I think there should always be pictures and instruction manuals. So I encourage students to draw what they are writing as well. So this is really fun because, it's a challenge in 2 ways. Like, can I follow the directions, but also can I write successful instructions? And you can make an instruction manual for anything. You can even make an instruction manual for drawing a smiley face. And that is something that can go horribly wrong. And that is another thing that you could do in Jamboard where you don't need a manipulative to make that happen. So another style of unplugged activity that we do, I feel like I have a million different versions of instruction manuals. And I feel like we come up with new ones on the regular. But another thing that is similar to an instruction manual is kind kind of dealing with randomness and instructions. So this is also really helpful to get the wiggles out. So I have some activity dice. I'm like, why does that look like an upside down J? Because the screen is weird for me. But we have a regular die. These are actually Vex Robotics cubes that I stole. And then this die has things like jumping jacks, touch your toes, skip in place for 10 seconds, jump as high as you can, hop side to side with your feet together. So this kind of helps kids figure out a little bit more of instruction. So you roll the dice, you end up with a 2 and skip in place for 10 seconds. What do you need to do? You need to skip in place for 20 seconds. And I clearly made these guys. And then again, I like Target, and I found these on clearance this summer. And so with this combo, you would have to hop on one foot 6 times, I guess, or do the duck waddle for maybe 4 links of the floor. Another thing that I think is such a bonus in a lot of classrooms that some folks might not notice is a lot of classroom floors have squares on them. So in here, our floor, as you saw in the video, is carpet, but it's squares. And a classroom, you might have linoleum or some other kind of quadrant sort of flooring. And I find that this makes it really easy to help give other students instructions. So when you're working in the maze, when you're building a maze, you have something to follow to make that grid. And with families, kids find it really, really entertaining to program the grown-ups. And I think that that dynamic might happen in a classroom as well, where it's fun to make the grown-ups do silly things, but that also instills the information to the students that when they are programming the computer, they're getting the computer to do what they need and want that computer to produce. So I feel like I've run through this and I didn't bring enough different activities to physically show you. But there are a lot of things that can build on the instruction manual. So when you're doing an instruction manual game or project, conditionals is a thing that you can add in to make it more complicated. So you can go from the very basic, get a yellow marker, draw a vertical line. If there is already a blue line, connect them. So you can add in if-then statements to these instruction manuals and make things a little more detailed and fun to do. Brian, do you have any questions? Does anybody have any questions?
I'm looking in the chat here. I don't see anyone just yet, but if you do have questions, go ahead and drop them in there. I do have actually one for you, Maggie, if I can. So I really like the instruction manual piece of that. I thought it was really cool. But you also talked about this idea of being able to tweak something or to make sort of this multiple of that idea. Can you talk a little bit about how you go about making some of those versions or different ideas for what's happening?
Yeah, so originally I showed you these, these 3 blocks. So you can give students the 3 blocks and you can give them matching markers. And there are less options, and it makes it it makes it more simple and leads them to success faster. But you could also just give these blocks to a high schooler and only allow them to communicate through written word. So not even spoken word, because as we all know, when we're talking, we're emoting, and there are gestures and things that go along with that, and maybe some unintentional pointing. And so you're challenging their creative writing skills, and you're challenging reading comprehension on both sides of this instruction manual project. And like I mentioned before, giving older students parameters on their instruction manuals, like it must include a conditional or an if-then statement. And you can always just pop a little extra detail into the parameters of their project. And even so, for the little bitties, I like just having these three blocks, but who knows where I put my Legos. So this Lego set has 6, but you could give them, they could make something super complicated out of 6 Legos, right? I have seen kids build all kinds of stuff. The most complicated instruction manual that I've ever seen written in Eureka Camp, we gave the students Play-doh. So we gave middle schoolers, there are the birthday party favor packs of Play-doh that are really tiny. So each student got 3 of those that were the same color. And one student made an object and then had to write an instruction manual on how they created that object. So with the blocks and the Legos, those are defined shapes. The Legos have attached numbers. Those are not going to change, but there are so many variables that go into the Play-Doh. For instance, they could mix the colors. So that gets very complicated. And I believe we had a 5-sheet instruction manual that came out of a middle school summer camp with Play-Doh. So kids can dive all in.
A 5-sheet instruction manual. Wow. You got them to write 5 pages in the summer camp.
Yeah. Right? I was not the kid who was going to volunteer for that.
That is awesome. Okay. We have another question in the chat here. So speaks a little bit about resources. So are there resources available somewhere that teachers can use? They said it would be great to find a lesson idea similar to the ones you shared today.
So we are working on that right now. The Eureka staff and our educator enrichment staff are actually working together to put together a group of kind of one-off activities that includes ways you can scale all of these activities. And so coming soon to a CodeVA near you. And the second question, We are not going to stop virtual workshops. We actually start in person again this week, and we do not plan to stop virtual anytime soon. And something that's really wonderful is we have students from all over the state participating. And the last class I interacted with, we had someone from the Eastern Shore and someone from Harrisonburg, and they had a really lovely conversation about like the difference of the geography. And I really love getting to see the students build community like that. And if you go to codevirginia.org, there is a student programs or student classes. And there is a classes tab. Here's the trick. It takes a second for our classes to load, but if you are patient and scroll to the bottom, all of our classes, both in person and virtual, are available for registration there.
What are some of the ones you guys have sort of featured, I guess, are you really excited about this time?
Yeah. So our in-person, this is a really fun free activity that we're doing right now. Each Thursday for the rest of the summer, we will be at a different Richmond Public School elementary school. And we will be doing outdoor unplugged activities. So we will be doing exactly some of the things that we talked about here. There is an instruction manual day where we will be doing it with sidewalk chalk. There is another day where there is a grid that you have to program your friend through, but there are blocks in it that they're not allowed to step on, but only the programmer knows what blocks can't be stepped on, not the robot. We also have, writing for video games is a really fun class that we have coming up in a few weeks. We also have, so right now a class that started yesterday is Pixel Art 101, and that one is very popular with the kiddos. We have a 3D design and printing that is project-based. So the students are solving a problem within their household and designing a 3D printed solution for that problem. And then we print the object and mail it to them at home. We also have a game jam class coming up. I'm like an app for pixel art. All of our classes use free software, and it is all either browser-based or downloadable. And to be honest with you, I'm not exactly sure what they're using for pixel art this go around. They have used GB Studios, which is Game Boy Studios, which is a software where you can make kind of retro video games. And they have used that a lot to create avatars and other characters. Trying to think, in the fall, we will have a virtual Critter Code, which Critter Code is my baby.
Tell us about it.
I wish I should have brought a critter with me. I can't believe I don't have a critter in arm's reach. Critter Code was inspired by a young student who was actually at an event we did just before CodeVA started. And this student was very shy, and I had laptop set up with Scratch on it. And I asked her if she had ever played with Scratch, if she was familiar with it, and she kind of was like, mm-hmm. And I was like, okay, well, I'm gonna make some stuff in Scratch. If you want to join me, you can. And she kind of came up beside me to the computer next to me, and she's, I'm not good at Scratch, but Cupcake, my stuffed animal dog that she had with her, is really good at Scratch. And she took Cupcake's little paws and tapped all of the keys, and Cupcake made an amazing animation in Scratch. But she's not good at Scratch. Her stuffed animal is. And this made me think about being a child and being an introvert and really loving my stuffed animals. So we created a class where students go through a design process for character development, and they make an all about me book about their character. They talk about all the different things that make that character a unique individual. They sew a stuffed animal out of socks. And then the same time that they're going through this design process, they're also learning how to make a video game in Scratch. And so they're experimenting and learning different things in Scratch, how to make a background shift when a sprite gets to a different place on the board, and adding scores and adding different variables and motions in Scratch. And so then towards the end of the class, they have this character and they have these skills in Scratch, and they design a video game starring their character. And they have this beautiful ownership. Like, this is mine. I made this animal and I made this video game, and there's nothing like it anywhere else in the world. And it's so fun to watch. Critter Code was designed for elementary school students, both early and late elementary. We have done it all the way up to early high school. And again, just like the instruction manual, this is a thing that you can scale to whatever your students need it to be. For middle schoolers, we have used modeling clay, and it has been a superhero specific character that they are creating. I have a super fast 45-minute version of Critter Code where we have 5 minutes with pom-poms and googly eyes and felt to make whatever you can in that 5 minutes. And then we make a very quick click game in Scratch. So they take a photo of their pom-pom animal, upload that to create their sprite, program the sprite to move randomly, and to get a point every time they click the sprite with the cursor. My dream is to see a group of high schoolers go through Critter Code. I think that combining the hands-on making and the creative writing that could go in with that character development, and then the richness of building the video game, that's my next goal, is to get some rich creative writing and video game building in there with a stuffed animal.
I will also chime in if I can on Critter Code and how much it has been awesome. So I had a chance to work with the middle schoolers doing it as well. So it is definitely something that can be adjusted for different ages across the board. And I still have my stuffed animal that I created when I was learning the programming curriculum. So it's definitely one that's exciting. And it's something about being able to, like you mentioned, to create something that doesn't exist anywhere else. So that's awesome. We're coming down to the last pieces of things. So if there are other questions, let us know. But I did want you, Maggie, to talk about a little bit, because you are sort of at the heart of integration in terms of being able to integrate arts and some of the other pieces that are happening with some of the computer science concepts. So just wondering, like, some of the approaches you guys take when you're thinking about a class or making sure that you are sort of presenting these ideas in ways that are fun and interesting to students.
Yeah, that's a great question. I think having a lot of the Eureka staff not coming from a programming background first has really helped us. And what we've kind of broken computer science down for us is the very first building block to be successful at programming any, even like physically building hardware, is you need to be a creative problem solver. So everything that we do starts with giving students open-ended adventures to explore and kind of have their own ahas about factual information on the way, but make their own path. We are here to support them in their discovery. And of course, with out of school time, that's our luxury, right? But in doing that, we are seeing what does make that aha come faster. And hopefully we'll be sharing this with you all soon as we're working with the educator enrichment folks. But I think for me as a learner, I need to see and feel how something works. And so I think the heart of the integration that happens in Eureka is just making things an experience. And it's like the critter code, I can really see that being a great example of a way to integrate computer science into a creative writing course. The same way the instruction manual could go into a math course. I mean, that's the perfect way to construct a word problem. And I think just breaking everything down and then kind of cross-pollinating the concepts is how we try and integrate computer science into the arts here. Does that make sense?
I think so. I think it does. I think that's sort of the idea that you're starting with how will students experience this, and then thinking about how can we make that something that is useful for them, and then incorporate those pieces that we're thinking about. The one thing I did want to add, the question was about resources and where those are. And while we are working on that piece right now, one place that you can go for sure is your Instagram, our CodeVA Instagram. And there's a lot of, we do a really good job of sort of sharing out lessons that are happening and courses and classes that go there, just for some inspiration pieces. We have a blog on our website as well and things that are happening as some good resources.
Another really great, just non-CodeVA resource that you all might have already shared is CS Unplugged. It is a downloadable book that was written by a gentleman in New Zealand. I probably should have come with that resource. But it's wonderful, and he continues to update it, and there are amazing activities in there that I have taken parts of and brought into our classroom And there are whole activities that we've done in our classroom. There's a lot of really great things with algorithms, and thank you, csunplugged.org. Thanks, Brian, for finding that so quickly. That's a wonderful resource. And there are some templates in there that is wonderful. Great, thanks for joining us, Allison, and have fun in your session.
Maggie, thank you so much for sharing. Just at the very least, a little bit about Eureka and the awesome things that are happening here, but then at the most, there's lovely activities that you had about this, and sort of the hands-on, and even some ways to present these things with the switching of the camera and things. I think there's some opportunities that have come. Hopefully it was valuable for those that were able to join with